Hi everyone. How do you graph y equals x to the 1/2? Well, what is that? That's the principal square root of x. And we've seen that before. It's this hook, and you must indicate the endpoint at the origin. This hook goes through quadrant 1. It gets flatter and flatter, but there's no HA. The square root of a million, the square root of a billion, the function values shoot off to infinity. But now, is the square root function an even function? Is the square root function an even function? Is it symmetric about the y-axis, the graph? And the answer is no. What's the problem? The domain of the function, what is the domain of this function? It's the set of non-negative reals. It is not symmetric about 0. We do not have symmetry about 0. For example, 1 here is in the domain, but its partner opposite value, -1, is not in the domain. So the square root function, although it sounds like it, it is not an even function. Now, the square root graph looks like the graphs for the 4th root of x, the 6th root of x, and so forth. Even for something like x to the 3/4 or x to the 5/8, where the exponent is proper, odd integer over even integer, you'll have similar graphs as these. Domain is the non-negative reals. Now, what about the cube root function? Y equals x to the what? X to the 1/3. That's the cube root function. What's the domain of this? What's the domain? It's not just the non-negative reals. The domain is going to be all reals, because you are allowed to take the square root of a negative number. You're allowed to take the square root of a negative, or sorry, you're allowed to take the cube root of a negative number, the 5th root of a negative number as well, all right? So the graph kind of looks like the square root graph in quadrant 1, and you get the origin, but it's an odd function. It is an odd function. Symmetry about the origin, the cube root of -1, for example, is -1. So the cube root function, again, I'm telling you how to think. You like cube roots. You like the odd roots. Domain is all reals. We get this S-shaped curve. It's an S curve, an S graph, and these functions are odd. So is the 5th root of x, so is the 7th root of x, even something like x to the 3/5 or x to the 5/9, where the exponent is proper, odd over odd. Next, we're going to see something strange. X to the 2/3 next.